So your teacher just asked you to solve some mass-to-mass stoichiometry problems, but you have no idea what to do. Well, this tutorial will teach you how to solve those problems so that you seem smarter than you really are. Before we begin the tutorial, there's two words you have to know: mole and gram. Both of these are two units of measurement. However, mole refers to measuring smaller particles, such as atoms. So here's our first example. It's an equation that has already been balanced. The question would read, how many grams of potassium chloride are produced if 25 grams of potassium chlorate are decomposed? So the first thing you do would be write what we already know, which is that there's 25 grams of potassium chlorate, which would be ClO3. Here you can just write it over the number 1. Then you'd multiply this by 1 mole of KClO3. Something to know is that this will always be 1 mole. Then under that you have to write the molar mass. This is what you get by just adding the atomic mass of each formula, which for ClO3 would be 122 grams. Now you'll write the mole ratio, which is the ratio between the two chemical formulas. So you would know which numbers to write by just looking at the coefficient in front. So it'd be 2 moles KCl right here, 2 moles of KClO3. To finish it all off, now you just have to multiply by the molar mass of KCl, which in this case is 74 grams, and put that over 1 mole KCl. You multiply across and you get 3,700. Put that over 244. And then your answer should be 15.2 grams of KCl. Here is our second example. How many grams of carbon monoxide are required to react with 50 grams of iron oxide? So again, we will just start with what we already know, which is that there are 50 grams of iron oxide. And then, like I said before, just put that over 1. And then this one will always be 1 mole. And then the chemical formula that you wrote before. Then you put the molar mass, which you add the atomic mass of iron oxide. Here it is going to be 159 grams. Multiply that by the mole ratio. So because it's reacting with carbon monoxide, we look at that. The coefficient is 3, and then there would be an imaginary one right here. So then you write that. Finally, you multiply by the molar mass of carbon monoxide over here, which is 28 grams. And put that over 1 mole. So after multiplying across, you should get 4,200 down here and 159 at the bottom. And then this should equal 26.4 grams of carbon monoxide.